Hey folks, welcome to this video. Thank you to Stage Precision for sponsoring this series of videos. Over the next couple months, you're going to see a couple of highlights and features about Stage Precision that we find really unique, exciting, and frankly useful in the industry. Our host for these videos is going to be Alloway of Matterform, so a big thank you to Ethan, who's going to share a lot of his personal experience having used Stage Precision on big broadcast TV shows, concerts, and live events. You're going to see Ethan talk about the overview of Stage Precision, what it is, what its use cases are, and he's going to quickly demo a couple of really interesting things you can do out of the box with Stage Precision. So stay tuned and enjoy.
Hey everybody, my name is Ethan Alloway from Matterform Inc. in LA, and we're going to be talking today about Stage Precision and just how it works as an app and an overview about why you might want to be using it. So let's dive in. So as you can see, I've opened a new project here, and let's talk about the different factors to what this app is going to be giving us. So we have objects, we have I/O connections. Over here, we have a pool, we have a timeline, a board, and a viewport, and an inspector. So in the Objects tab, it's going to be a right-clickable area where we can choose between different operators, which create different objects for us. Down in I/O connections, we can also right-click. These are going to have different types of I/O connections. Next to that, we have pool. The pool, think of it as sort of a group for your variables, different types of actual data objects. Up here, we have the timeline. The timeline is an area where you can right-click and create new types of triggers or keyframes or different variations of that. Then you have board, of which you can right-click and choose between different GUI options or different operators. Very similar to TouchDesigner if you guys are experienced with that. The GUI also feels a lot like Zero Density's system with their operation system. Below, we have viewport. The viewport is a 3D viewport. So let's add a skeleton, for instance, and that's centered around the 0 point for that. So we'll scooch it up. So here we've got this little object. Our base grid is in meters, and that's going to be how we're going to be working with this. Thankfully, it is very similar to TouchDesigner and Unreal. We can click on a position and type it in manually, or we can also click and then scroll with our scroll wheel where we want that to go, in which direction. So let's talk a little bit about why you'd want to use Stage Precision in certain environments. Some great examples are virtual production, which needs tons of I/O, tons of specific data, a lot of offsets and specific management of those tracking systems. Another great example would be live stage. I mean, it's in the name. Stage Precision is a great way to be able to open up, let's say, an FBX file, explore the stage, figure out where things can physically land and actually work in a literal way in the scale of how objects are really going to be. I use it pretty often for actually just doing a layout and finding out how things are going to fit together, and also if certain cameras are able to line up with their zooms at maximum distance. Well, maybe you don't know if it's going to work. This allows you to actually temporarily put things together, really temp things out in a blueprinting way, and then also it could run the entire show for you, which is great. Another great example would be for real-time lighting or real-time tracking systems. It takes in so many different types of I/O that you're really just able to bridge gaps that would not be bridged together normally. A lot of times you would have to create your own script in TouchDesigner to be able to do these things. And I love doing that in TouchDesigner still. However, for efficiency's sake, this is a great app, and it just does it the right way from the very beginning. Allows you to just put building blocks together instead of getting really granular and specific. This allows you to just simply grab things, plug them into each other, and also control data using other data sources. A good example of that would be that Stage Precision is the perfect middleware in between two pieces of hardware. What you would potentially have happen is a camera system that only comes from one vendor might need to end up going to another tracking system or a computer that can only listen to a certain protocol. This allows you to take, let's say, Stipe HF or Blacktracks and convert that down to positional data inside of SP. You can then choose however you want to get to the other computer. This might be an example to use OSC just to do specific locations. You could convert that to FreeD protocol. You could convert that to tons of different protocols. I mean, you can see the list is gigantic here, and it's just going to keep getting bigger. You can also use this to grab I/O from physical sources like serial data, or even from fidgets, which are great little hardware devices. So if you need a method for being able to work with, let's say, sensors and buttons and things, this is also a great resource for doing that. You can also control and use control from media servers to be able to trigger these items. So you don't necessarily have to go through a Grand MA or a lighting console to be the master of the show. You might be able to listen straight from the media player to know when things are going to happen. You can grab from tons of great examples like Pixera and Disguise and Pandora's Box to be able to know where you are, let's say in a clip, or to control clips. It also allows you to work with different hardwares such as switchers and PTZ cameras and lights and things like that. You're able to grab the active input on an ATEM. Maybe there's something that you need to have where it only starts the second that camera goes live, and then the show plays from that point forward. This is a great example of how you could do that. So the timing is just perfect. You also have the ability to grab synchronization. You can get LTC. You can also get MIDI timecode and also media input using NDI or SDI. Using a media input for SDI allows you to grab the genlock downbeat of actually when things happen precisely. I'm assuming one day we'll probably see PTP and other different really specific timing syncs come into play as well. You can also grab from kind of funny stuff like Philips Hue or like PJ Link and stuff like that. So what I typically say to people when they're asking about why would you use SP is if you need something that A needs to be plugged into C and you don't have the B yet, this is a great example of how that could work. It also works really well as a standalone app to be able to create and design bigger systems, which are able to be controlled through multiple computers. You can create backups with this, and it's just a really wonderful system. So you're able to do many different things with the software, and I think it's a really versatile piece of gear. One thing that it also can handle is LiDAR data, very lightweight, and you can actually volumetrically track the LiDAR data to look for the average position of a point cloud. A lot of times in installations, we're using blob tracking with orthographic angles, let's say, to know where the heck a person is. This is actually able to just simply send all of that really tough LiDAR data out and then just grab those point positions and turn them into an OSC value, which could give you an XYZ as a tracking point. Is a lot easier than having to create a bunch of multiple blob tracking systems, which are super CPU intensive, super hardware intensive for your GPU as well. And this just allows you to free up computers so they can each do their own respective job and also create protocols, which are just way easier to work with for everybody else. So let's now open up a different project. This project that I have coming up contains a bunch of really fun stuff. This is going to show different examples of how things could work and ways that I might set them up. All right, so now we're going to look at using an Orbeck camera, for instance, to do point clouds. I have this selected, and I click over to Orbeck sensor. We choose network device. We drop down to click our Ethernet path. We type in the Orbeck's Ethernet, and here we go. Here's my data. Now, in this scenario, this computer is running quite slowly because I'm also screen recording right now, but we are able to take a look at using a camera parented to our Orbeck sensor, and we can actually look through that camera. Oops, wrong camera. Camera 2. Let's zero that guy out. And let's just increase our field of view. So what's cool here is that we're actually able to use the Orbec to do tons of hard work that we would have normally had to do in TouchDesigner for us right here. We're able to filter it. We can crop, we can take the actual image and cut around it and mess with it. We can also mess with the point clouds as well. So the VBO is where you're able to affect your point clouds. We can clip it from near to far. We can also mess around with the background. We can mess around with outliers, which are going to be points that are off in the distance. We can also use clustering, which is really interesting. And this is how we're going to be able to do some of the blob tracking systems. So we can do tons of really cool stuff with point clouds, and we're going to look into that a little bit more later in one of the coming episodes. All right, so now we're going to work on applying a look at object or a tracker to be parented to a skeleton bone. We're going to parent it to my left hand. And here, what we need to do is we need to first take the look at object and parent it under the skeleton. Then we go through and we apply a filter map in this scenario using the target option. We're going to follow an object. Now here, we're going to then choose the skeleton, which is at the bottom. They have the same name. Now, as you can see, I'm moving around, but nothing's actually happening. What we have to do is we have to actually turn on the points and then choose one of the points. So let's then go up to find where it hits my hand. Should be like my fingertip. There it is. Perfect. So point 22 for us. Again, hide that. Okay, great. This is working well. So what we can do is we can actually create a second object. So let's add another tracker. We're just going to put this in here. We could probably just parent it underneath or make it a child of the skeleton. Then we can do, take the input and have it follow the lookout point. And you can't see it right now, but that's actually because it's behind it. So now we can smoothen this. There we go. Okay, cool. So now what we have is we have a real-time control. We also have a smoothened point that's following it. What's nice here is that we can actually make this the item that things would look at. That way, no matter how stuttery, just like there, my connection gets, it's always going to have a smooth path to follow. That's really helpful for having bad data, but just sending a couple of hand points. You're not sending the exact point exactly when it happens. It's a lot safer to go this way, because then Stage Precision is able to actually interpolate that data and smoothen it out for you. It's much nicer for it to work with. All right, so now we're going to be taking a look at this project, which has a bunch of different little pieces to it. Let's go through the overview really quick so we can see what we have to work with. I have these all built into different folders for our ability to just quickly hide things as well. So let's go through the basics. The GUI gives us all of these fun little pieces to work with. So the GUI folder, I have a camera, a tracker, skeleton, plane, mesh, PTZ camera, and some light fixtures. These are all hidden right now. This is what it looks like with them all on. Let's just go through and hide all these and go through them one at a time. And let's also hide. Yep, okay. So obviously our camera is a camera. That one's pretty easy. Tracker, as we went through earlier, is one that allows us to move around the world, which also gives us trail data to tell us where something was. You can literally just put trackers parented or nested underneath a bunch of other things just to be able to have as points to check around. They don't do anything. They're kind of like a null object. We have skeletons. Skeletons allow us to import data, such as connect data, which is really nice for like a stage environment where you might want to be able to track talent moving around. You can also use similar systems. We also have planes and other various geometry types. There's also a whole list of objects here, which are just primitives to be able to use, like cone, cylinder, cube, even splines. Splines can actually allow you to create paths for different things as well. But mesh is the next one, which is great. So here is a cyc that I've built. This is the cyc for Lulu AR stage. Some friends of mine in LA that I work at pretty often. This is their stage that I've created a one-to-one replica of in Blender. This just allows us to be able to know where spatially we are. It also is really useful for being able to be a reference point for physical trackers. If we tape something down, we're able to check it and then move to that location, make sure it's measured to that distance. We also have a PTZ camera. This is a great tool if you work in any sort of broadcast space, or maybe you're doing presentation work where you want a camera to be able to follow you. We're going to talk a little bit about that eventually. There's also light fixtures. Light fixtures are awesome because you're able to track positions with them as well. So pretty much almost everything in this app has a method of targeting something, which is super cool and really helpful. Next, we have utilities. The utilities, we're going to talk about, let's see, targets. So targets, we've got these little billboard looking target things. Let me hide this. So target, which is this one, and then a target frame, which is this one. So a target is a look at point, just like a tracker really would be. It's just a different name and allows you to do a couple of different things. A target frame is cool because a target frame, where a target is a point, a target frame is almost an entire space, and it's kind of like a 2D cutout of your target location. So in this scenario, it'd be really useful to use a target frame for something like a person, where a person walks in, but you want to frame it to where it shows at least a cowboy shot from their hip up to the top of their head. This is a great use for that. You can change the scale of that target frame and also the width of it. Then we have measurement tools. These are great. These allow us to take two different points. Let me scroll this over. There we go. And find out something about them. Here we can find that these 2 points, their distance is 2.44 meters away. I can move this and dynamically find out the scale of that measurement. And then we can also find out the angle of those two different vector points, which is really helpful if you're trying to figure out where something is aligned. So here I can see that my measure A is, over here. Measure B, let's move this over here. And we can find out that the x-axis difference is 175 degrees, the y-axis 98, and so on and so forth. Now let's look at center point. So center point allows us to actually look at the location between all of these different points and find the average center of them. To do that, we're using the object called rigid body. I'm sure that there are many other use cases for this object, but right now I'm finding this is a really cool one for me. So what we can do is we can actually use it to triangulate through different positions the dead center point of it. So if you're needing to check the average position between a bunch of different points, this one is pretty good for doing that. It allows you to also essentially take all of the different vectors of those inputs and then average them out. So you can imagine a couple of different use cases for that. One of the ones that I really like is if you had dynamic geometry that moved all over the place, you could actually go through and find the middle point of that. This can also be used for creating physical planes which are parented to that. So let's say that you had the four corners of a LED wall. You can find those four corners in space using a tracking system. And then what you can do is you can actually use this to snap that plane in real life, or sorry, in digital space into the location that it is in real life, which is a really cool tool. So yeah, these are a couple of examples that I think are helpful to look at when considering why you would want to use stage precision. I always consider how I can put it into my workflow, and definitely would recommend it for yours.
Hey folks, thanks for watching. If you like our YouTube content, I highly recommend you check out the Interactive and Immersive HQ Pro. The HQ Pro is the only comprehensive educational resource and community for immersive design, TouchDesigner, and creative tech pros. In the HQ Pro trainings, we cover almost any topic you can think of, and we go way more in depth than we do in our YouTube tutorials. We have a private